As an example, we want to determine the representation corresponding to this one column diagram, a representation of S3. So the Young operator for this one column diagram, that's the total antisymmetrizer, which we wrote by a solid bar over the 3 lines. Here we have an element of the group algebra. So first we have to find out what the space is to which this Young operator here projects. So we have to calculate what is Q times this Young operator. Okay, and we can do this with the individual terms. So let's just take the Young operator, and now if we write the identity here, then clearly it's again the same Young operator, the antisymmetrizer. If we multiply this with this transposition, well, then we can just interchange these 2 lines here, which leads to a minus sign. So we get minus our antisymmetrizer here. And that's not only true for this term, but also for this one and for this one. Now, if instead of this transposition, we put one of the cyclic permutations here, then we could, let's say, first interchange these 2 lines, then what happens then? Was that a good choice? Maybe not. Maybe I'd first interchange these 2 lines and then these 2 lines. It doesn't matter. I just interchange twice and then I get -1 squared. So I get a -1 for each interchanging of lines. So I get again the antisymmetrizer back. And that's the same for either of these cyclic permutations. So in total we get Q1 minus Q2 minus Q3 minus Q4 plus Q5 plus Q6 times the antisymmetrizer. So no matter what we put in from the group algebra, we always get back something that's proportional to the antisymmetrizer. So we found the invariant subspace corresponding to this diagram here, and that's just the span of the antisymmetrizer. Okay, and if we now want to know what's the representation that lives on this subspace, we have to act with our group elements on elements of this subspace. But that's just the calculation we already did. We know what happens when we multiply a group element and the antisymmetrizer. So we already know the representation matrices, which are just numbers here because it's a one-dimensional representation. This is a one-dimensional space here. So gamma corresponding to this one here of the identity, that's just 1, and it's the same if we put in one of the cyclic permutations. And same for the other cyclic permutation. And if you put in one of the transpositions, then we get -1, and the same for the other transpositions. Okay. Now we found the subspace of the group algebra corresponding to this Young diagram, or Young tableau. It's a one column Young tableau, the only standard Young tableau with this diagram. And we found the representation matrices for the irrep that lives on this subspace.